So today we're going to look at specific heat and how to calculate the amount of heat that we get from reactions. So we're going to start with these word problems. And remember, our first step with all these word problems is pulling the information out of the problem. So that's the first thing we're going to do. And I'm going to do that as I'm reading the problem. Okay? So it says, how much heat? So right away that tells us our question mark is going to be Q. That's what we're looking for. Is absorbed. Heat being absorbed means that it is an endothermic reaction and our Q is positive. So I'm going to put a little plus there to remind me that said it was absorbed. Our Q is positive. And that should agree with our answer in the end through the calculations. And it is absorbed by 20 grams. So grams means that we've got mass. So the mass equals 20 grams. Don't forget the decimal point because we've got to watch significant figures of granite. As the temperature changes, this delta just means change, from indicates that this is your initial temperature. So our initial temperature, T initial, is 10 decimal point degrees Celsius. 2, this indicates that this is our final temperature. Temperature final equals 29 degrees Celsius. And then it says our specific heat, our C, happens to be 0.1 calories. And remember, this the slash line means that these guys are in the denominator. So we're going to write it as a fraction over grams degrees Celsius. So we need our specific heat calculation and our specific heat equation. So that is basically that Q equals Cm delta T. Remember that our delta T is always T final minus T initial. Okay? I'm going to do this delta T separately from the rest of the equation because if we're keeping track of significant figures, remember our significant figures with addition subtraction are different than our significant figures that we're going to have for our multiplication over here. So to make sure I keep everything straight as far as significant figures, I'm going to do these calculations separately. Okay? So over here, we can right away do our delta T equals 29 minus 10, the decimal point, which equals 19 degrees Celsius. Now that we have the delta T calculated, we can go ahead and do our straightforward equation here. Our Q equals our C, which we have down here, 0.1 calories per grams degrees Celsius. Remember to keep all the units in there. We're going to multiply it by our mass. Our mass is 20 with the decimal point grams. So 20 decimal point grams. That goes in the numerator. Remember, any number is like it's over 1. So that goes in the numerator. And our delta T is 19 degrees Celsius. 19 degrees Celsius. Check our units. Grams are going to cancel out with grams. Degrees Celsius are going to cancel out with degrees Celsius. And then we can go ahead and do this calculation. And we end up with 38 calories. Now we always have to ask that question about significant figures. So let's look at significant figures. We already did the significant figures over here. It was to the ones place, so we know that's good. Here we've got one significant figure, two significant figures, and two significant figures. So we only need one significant figure in this answer. So if we only need one significant figure, we need to round this, and we're going to round up. So the answer is 40 calories. And our 40 calories is more precise than the 38. because of significant figures. All right, so hopefully that was a straightforward one. We just plugged it into the equation. Let's look at it as another problem. I'm going to shift this down here so we can focus in on this problem down here. Here we've got a problem that says we have 4.50 grams. Now, grams tells us that it's a mass. So I'm going to say the mass is 4.50 grams of a coin that is copper. And it absorbs 54 calories. So this is how much heat. So that's our Q. And the fact that it absorbs means that it's an endothermic reaction. And so our Q has to be positive. So when I write the Q and I take this out of the words, we are going to say it's plus 54 calories. Okay. Now it asks, what is the final temperature? So our question is temperature final. If the initial temperature was 25 degrees Celsius, so temperature initial is 25 degrees Celsius. And then we're told that our specific heat is 0.092 calories per gram degrees Celsius. Okay. So we're going to start off with our equation. Our equation says Q equals Cm delta T. Now this is another, we're going to keep the delta T as that, and we're going to do two separate equations for this, because it'll make it easier than trying to do all the math with T initial and T final in your one equation. Okay, so watch how I do this. We want final temperature. Well, that's part of delta T. So we have to solve this for delta T. So what we're going to do, how did you solve anything for a variable on one side? Okay, we're going to divide by Cm on both sides. That means our delta T is going to equal Q divided by C divided by M. Okay. Let's go ahead and plug those in. Our Q is 54 calories. Now I'm going to give each thing its own space in our grid. Our C has to go in the denominator. We're dividing by it. Remember, it's a fraction, so we have to flip it upside down. So it's 0.092 calories, and then the grams and the degrees Celsius go on top because we're multiplying by the reciprocal. Now we're dividing by the mass. The mass is just a number, so we're going to put that in the denominator. Now before we do any of the calculations, we want to plug it into the calculator. Before we plug it into the calculator, we're going to have to check our units. So grams, cancel out grams, calories with calories. The only units we have left are degrees Celsius. And we ask ourselves, is that a valid unit for temperature? Yes, it is. So it seems like we're on the right track. So let's go ahead and plug these guys in. 54 divided by, 54 divided by 0.092 divided by 4.5 equals, we get 130.43 degrees Celsius. Now we have to check our significant figures because we're done with our multiplication here. We've got two significant figures here, two significant figures here, three significant figures here. So we need two significant figures in our answer, which means we're going to be 130 degrees Celsius. Now, is that our final answer? Well, no, we were asked for final temperature, not delta T. Not a problem because delta T equals final minus initial. So we can solve for final. we're going to add t to both sides. So our t final equals delta t plus t initial. Okay. Let's go ahead and plug those numbers in. We've got 130 degrees Celsius plus our 25 degrees Celsius. Let's go ahead and do the math. And we get 155 degrees Celsius. But remember, we need significant figures here. So here, with addition and subtraction, the significant figures are different, right? Here, we've got significance only to the tens place. Here, we've got it to the ones place, but it's only to the tens place where we have significance here and we have significance here. So we can only go to the tens place here to get significance, which means we have to round this. This is above 5, so we're going to round up. So our final answer is 160 degrees Celsius. So you can see how that would be really difficult to do if we had put the temperature final minus temperature initial in our first equation here and tried to do it. By separating it into two separate reactions, it makes us be able to keep track of our significant figures in a more straightforward way. Okay. So I do suggest you solving for that delta T first and then going through and trying to find the final temperature. All right, let's see if we have time for one more as we are with our videos, as all my things fall down here. Let's try one more. Here we've got a temperature of iron with a mass. So the mass equals 10.0 grams. The temperature changed from, so our initial temperature is 50.4 degrees Celsius to, that means our final temperature, T final is 25.0 degrees Celsius with a release of heat. So our Q, if heat is released, it means it's exothermic. Exothermic means that Q is a negative number. It happens to be 47 calories. It asks what's the specific heat. So this time our question mark is our C. Okay. Just like before, I'm going to go ahead and do our delta T as a side reaction here. It's final minus initial. Keep in mind, this will be a negative number, which corresponds with the fact we've got a negative there. So let's go ahead and do that. 25 minus 50.4, and we get 25.4 degrees Celsius. Our significance is to the tenths place, so the answer is to the tenths place. Now we'll go to our equation. Q equals Cm delta T. And this time we are solving for C, which means we're going to divide both sides by m delta T. Those cancel out, so we've got C equaling Q divided by m delta T. So let's go ahead and substitute those in. Our Q is a negative 47 calories. We're going to leave space for everything to have its own thing. Our m is in the denominator, and it's 10.0 grams. Our T is in the denominator, and it is 25.4 degrees Celsius. So now when we do the units here, we got to remember that was a negative number. Okay, don't forget our negative sign there. When we come through here, the negatives are going to cancel out. Our units are going to be calories on the top and grams degrees Celsius on the bottom. So our units are working out. Let's go ahead and do the calculation. 47 divided by 10 divided by 25.4, and we get 0.19 calories, considering we need two significant figures because this has two significant figures. So we've worked some problems with significant figures, and hopefully you're understanding